So today we are going to talk about neutralization and titration. A neutralization reaction, as you might guess by the name, is going to result in neutral products. And it is going to be basically, the formula is acid plus base is going to yield water and a salt. And by salt, we just mean ionic compound. So for example, if we have HCl, that's our acid, pH is going to be very low. NaOH, there's our base, pH is going to be very high. We put them together, it's just going to act like a double replacement reaction where hydrogen and sodium are the positive ions that are trading places, and that's going to result in NaCl, and you could say HOH, but of course that would just be H2O, right? And the result of that should be a solution with a pH of 7. Now that's only if the acid and base are both strong, and HCl and NaOH are both strong. Then the NaCl, the salt, will be neutral. And we'll talk about why that is a little bit later on. But for now, we're just going to understand that it's a neutralization reaction. The water and the salt are the products, and they are not going to increase or decrease hydronium concentration or hydroxide concentration, so the pH should be pretty close to neutral. All right, let me give you a couple more examples, and you can pause and just attempt these. Okay, so aluminum hydroxide and nitric acid, and then let's also try H2CO3 plus we already did NaOH, let's do KOH. Pause and give those a shot. Okay, so the first thing to do, just like any double replacement reaction, you're gonna pick the positive ions in each one, and those are gonna be the ones that trade places. So aluminum would now be paired with nitrate, and the other product would be HOH, which of course we can write as H2O. Balancing wise, looks like we can try, at least initially, putting a 3 to balance the nitrate. That's going to give us 6 hydrogens on the left if we count these 3 and these 3. So maybe put a 3 in front of water, and I think that one is balanced. Okay. Then our next one, the hydrogen and the potassium are trading places. So we are going to get water, of course, and we're going to get potassium carbonate, K2CO3. And again, we'll try balancing with the 2 in front of KOH. And I think that's going to give me 2 oxygens on the left, aside from the carbonate, of course. So probably going to have to put 2 in front of water. And I believe that gives me 4 hydrogens on each side as well. So that is neutralization. Very simple. It's just a double replacement reaction, only you don't have to worry about forming a precipitate because instead it forms a molecule. It forms water, right? Okay, the other thing we need to talk about is titration. And it's a fancy sounding word, but basically it just means you have 2 solutions. One of them you know the concentration of, and the other one you don't. And so we're using one reactant to find the concentration of the other. So we'll just get right into an example. The molarity of H2CO3 is unknown. So if we have 32.5 milliliters of it needed to neutralize 19.0 milliliters of 0.800 molar LiOH, what's our unknown molarity? So the first thing we need is a balanced neutralization reaction. So go ahead and pause now and see if you can come up with one of those. Okay, so there we go. We have our balanced equation. Lithium carbonate and water are our products. All right, so if we're looking for an unknown molarity, we have a volume of our H2CO3, right? And then we have both a volume and a concentration of our lithium hydroxide. So we are simply going to do some stoichiometry because molarity, of course, is moles per liter. Well, we already essentially have the liters, so all we need are the moles. And we can find the moles by starting with the volume of the known solution. So in this case, 19 milliliters or 0.019 liters of LiOH. So that we can convert to moles, right? Because we know the molarity. So the molarity of the LiOH in this case is 0.8 molar. So that's 0.8 moles per 1 liter. And then from moles of lithium hydroxide, I should be able to go to moles of my acid. So we have moles of H2CO3 on top. And this, according to my balanced equation, was a 1:2 ratio. So if I calculate my moles, okay, so that should give me my moles of H2CO3 is 0.0076. The last step is to simply divide by liters, right? Because molarity is moles per liter. And if we look up here, we have 32.5 milliliters, which would be 0.0325 liters. And so if I punch that in the calculator, just divide my previous answer by 0.0325, gives me a molarity of 0.2338. And I'm going to stop that at 3 sig figs, so 0.234 it looks like. And that would be molar H2CO3. And that is how we find an unknown molarity in a titration calculation. I'll go ahead and let you try the other one there on your own, and we'll go over it in class. Let's go to one more type of problem. It is also possible that we can find an unknown volume. So same kind of reaction, neutralization. This time, though, we're looking for the milliliters of sulfuric acid. We know the molarity this time, and we know the volume and the molarity of the base. So go ahead and come up with a balanced neutralization reaction. We'll start there. Okay, so there's my balanced equation. Hopefully you got that. Now, we're still going to start with the volume of the one that we know the concentration of, only this time because we're looking for volume of the other one and we have the molarity, we can do this all in one long stoichiometric step. So in other words, we don't have to stop and divide by anything. We can just kind of do this all with fractions. So we're going to start with our 70 milliliters or 0.07 liters of aluminum hydroxide and see if you can take that all the way to milliliters of our acid. Okay, and so here is what it should look like. Starting with my volume of my base, I did convert it in my head to liters, 0.07, and then to moles using the molarity, right, 0.875, and then use the balanced equation to go to moles of H2SO4, then use the molarity. This time we had the molarity of the sulfuric acid, so that was 0.5 moles per 1 liter, and then of course multiplying by 1,000 because it asked us for milliliters. And hopefully if I did everything right, I got the correct answer, 184 milliliters of H2SO4. Okay, and that is neutralization and titration.